Sprites are the heart and soul of Game Boy games. They are used for characters, enemies, bullets, special effects, and more. Game Boy games can utilize up to 40 different hardware sprites. Often, multiple hardware sprites are used to draw one single object. There is one caveat to that though. Individually managing multiple hardware sprites can become a tedious and complicated task. This becomes especially true when you're managing multiple objects that each require multiple sprites. This is where the GBDK support of Metasprites comes in. GBDK Metasprite support makes it easier to draw and animate objects in your game. In a previous tutorial, I showed you how to directly draw and manipulate sprites. In this tutorial, we're going to simplify that process using Metasprites. As always, if you need help, check out the video description for more links. There, you'll find links to the GBDK Discord, the GBDK documentation, and my own website. For this tutorial, I'm going to speed through some things not specifically pertaining to Metasprites. Feel free to pause the video, rewind, or ask a question in the comments if you need help. We'll first clone the minimal template, include our graphics into the project, populate VRAM with the tile data for our graphics, enable the 8x16 rendering of hardware sprites, and turn on the display. In this demo, we're going to have two arrows moving on the screen. One will be controlled by the player, the other will move to the player's position when the player is not moving. Above our main function, we're going to create 6 variables. We'll have 3 variables for each arrow: the arrow's X position, the arrow's Y position, and whether or not the arrow is facing to the right. Back inside our main function, we'll initialize these variables. We'll put the player's arrow near the bottom and the other arrow near the top. Both arrows will also by default be facing to the right. In our game loop, when the player holds down the left or right D-pad buttons, we'll move the player arrow left and right respectively, also updating which direction they are facing. For the other arrow, we'll first check if the player isn't holding down the left or right D-pad buttons. If that's true, we'll move it to the player arrow's X position. With all that done, we can finally get started on the Metasprites implementation. GBDK gives us several functions for using Metasprites. Each of these functions takes in which hardware sprite to start with and returns how many hardware sprites were used in total. This makes it easy to render multiple Metasprites using a simple counter variable. Each of these functions takes in the same 5 parameters. The first parameter is a pointer to your Metasprite. We'll get to that in a second. The second is the base tile parameter. This tells GBDK where the Metasprites tiles start in VRAM. The third parameter is the base hardware sprite. The Game Boy only has 40 of these, and each call to the function will use a few. How many each function call uses will be returned by the function. The fourth parameter is the X position to draw the Metasprite at. The fifth and final parameter is the Y position to draw the Metasprite at. As I'm recording this video, there's plans for changing the Metasprite function names. For future watchers, here are the new function names if you get the GBDK 4.2 release or higher. I'll show you how to use these functions, and afterwards we'll walk through creating a Metasprite. In our game loop, after the logic for our other arrow, we'll start by creating a variable called starting sprite. This will be used to keep track of which hardware sprites we can use. In this example, we're going to use the move Metasprite function and its sibling function, move Metasprite VFlip, that draws the Metasprite flipped horizontally. We'll do this twice, once for the player arrow and again for the other arrow. If the player arrow is facing to the right, we'll call the move Metasprite function. We'll pass in our arrow Metasprite as the first parameter, 0 for the starting tile, the starting sprite variable as our starting sprite parameter, our X position, and our Y position. We'll add the result of that function call to the starting sprite counter variable. This will prevent the next arrow from accidentally stealing any hardware sprites. A reminder, we haven't yet created our arrow Metasprite. We'll do that at the end. If our player arrow is not facing to the right, we'll do the exact same thing, but with the move Metasprite VFlip function. We're almost done with our game loop. We'll do the same thing one more time, except for the other arrow and using its variables. If it's facing to the right, we'll use the move Metasprite function and add its result to the starting sprite counter. If it's facing to the left, we'll use the move Metasprite vflip function and add its result to the starting sprite counter. The last thing we'll do isn't specifically associated with Metasprites. We'll use the final value of our Metasprites counter with a function called hideSpritesRange. We'll pass our counter as our first parameter and 40 as the second. This function is simply going to hide all unused hardware sprites. This isn't particularly necessary in this tutorial because the number of hardware sprites used is constant. However, in real games, where the number of hardware sprites used may vary, this will prevent unused sprites from lingering around. With that said, let's cover creating an actual Metasprite. First, we'll add an include for the Metasprites header file. Next, we're going to create a single Metasprite. We do this by defining a constant array of Metasprite t-structs. In this tutorial, we'll be drawing an arrow that uses 3 8x16 hardware sprites. We're going to have one array item for each hardware sprite, then a final terminator entry. For the first entry, we'll define a Metasprite t-struct with the following values. First, there's dy and dx. These signed 8-bit integers dictate where the first hardware sprite will be drawn. dy and dx are relative to the previous array item's drawing position. In the case of the first array item, dy and dx are relative to the position passed in when we first called the move Metasprites function. The next property is called dTile. This is what tile you want to draw for this hardware sprite. This value is relative to the base tile provided when you called the move Metasprites function. The final property is called props. This is used just like the set sprite props function. It can flip sprites, change priority, and even change their color palettes. Let's create our arrow Metasprite. Our arrow is 24 pixels wide and 16 pixels high. We want the pivot point of our Metasprite to be in the middle. For that reason, for the first array item, we'll set the dy and dx to be half of that and negative. The first hardware sprite will use the first 2 tiles, and we are not going to need any special properties for any of our array entries. The next hardware sprite will be drawn 8 pixels to the right of the first. For that reason, we'll set dy to 0 and dx to 8. The second hardware sprite will use the third and fourth tiles, so we'll give it a dTile value of 2. The third and final hardware sprite will be drawn 8 pixels to the right of the previous, and we'll use the fifth and sixth tiles. Its dTile value will be 4. Now that we've got all our hardware sprites defined, we just need to add the terminator item. This is important and lets GBDK know we're done. That's it. If we compile and run, we should see 2 arrows. One arrow we can move with the left and right D-pad buttons. The other arrow will move to us when we stop. If it seems tedious creating a bunch of Metasprites for your game, there's a solution to that. The PNG to asset tool provided by the GBDK automatically can create Metasprites from PNG files. I have a written tutorial on this. I'll create a video for it in the future. Also, I'll again state that the GBDK is a living and growing project. As I'm recording this video, there's plans for changing the Metasprite function names. For future watchers, here are the new function names if you get the GBDK 4.2 release or higher. If you enjoyed this video, click the like button and subscribe for more videos. If you need help, you can leave me a comment below, send me an email, or tag me in the GBDev or GBDK and Discord servers. Thanks and have a great day.